Class 11th, I am taking the collision. You have heard the name collision, that whenever two bodies are moving in a straight line and they come close to each other and they have the impact, then the direction of their velocity and the direction and magnitude of their velocity changes due to mutual interaction. This phenomena is called the collision. When two moving bodies come close to each other, and they collide. The direction and magnitude of their velocity change due to mutual interaction. This phenomenon is called collision. So interaction is what? That when they collide with each other, then one body apply the force on the another and another body apply the force on the other. So there is the action and reaction, and because of that the bodies change the magnitude and the direction of their velocity. Either both of them or one of them is changed. The colliding bodies apply force on each other that is i.e. action and reaction. Acts on the bodies. So this is like this. This is, suppose this is now body, this is moving here, and this body, this is also moving, and then they collide with each other. Then they apply the force on one another. So this net force here, this is equal to 0. So the force applied by one body is equal to force applied by the second body. If suppose we are having this the body, this is now 1 and this is now suppose the body 2, then this F to 1 is equal to minus F12. So what we have? F21 plus F12, this is equal to 0. So this is what? The net force. F, this is equal to 0. So net force is 0. It means that there is always the conservation of linear momentum. So in all kinds of collisions, the momentum is always conserved. In all collisions, the law of conservation of linear momentum is followed. Because this net force comes out to be 0 here. So we are having, this is what the law of conservation of energy, that in absence of the external force, there the linear momentum of the body remains the constant. So this is what that we have the action and reaction. This is the mutual interaction. This is called the mutual interaction. Mutual interaction. So this is what the Newton's third law of motion. Newton's third law of motion. So it is means that collision follows the Newton's third law of motion. Now on the basis of the elasticity, the collision is of two kinds. On the basis of elasticity, the collision is of two kinds. One is the elastic collision, and second, the inelastic collision. Now let us see that what is the elastic collision. In elastic collision, the linear momentum is conserved, and so also the energy, the kinetic energy of the system is remains the constant. So they follow the law of conservation of energy. Elastic collision. The collision in which law of conservation of momentum and energy are followed is called elastic collision. Is called the elastic collision. The collision in which law of conservation of momentum and energy are followed is called elastic collision. So what we energy is what? The kinetic energy. So in collision, net force F, this is equal to 0, as I have told you here. It means when F is equal to 0, the bodies are not accelerated. So they move with the some uniform velocity. F equal to 0, so potential energy of system, this is equal to 0. Then we are having only the kinetic energy. Kinetic energy of system remains constant. This is what we have here. The energy is conserved. It means the kinetic energy is conserved. Because the force is not acting there, so there will be no potential energy at all. So we are talking only about the kinetic energy of the system. So we say that kinetic energy equal to constant. It means that kinetic energy before collision and kinetic energy after collision are equal. Kinetic energy before collision equal to kinetic energy after collision. This is what we have the meaning of this. The kinetic energy of a system remains constant. So now we can have the examples of elastic collision. Examples. There are so many examples. Collision between microscopic particles like electron collision, electron proton collision, and the atomic collisions, the collision between atoms, collision between atoms and molecules, the alpha particle scattering, etc. So all the microscopic particles, they have the elastic collision. and there the kinetic energy and the momentum both remains constant. Now in case of inelastic collision, the collision in which linear momentum is conserved but kinetic energy is not conserved is called inelastic collision. So all the collisions that you see in our daily life, they are the inelastic collisions. Now the examples, and this inelastic collision, the net force is again equal to 0. Net force F, this is equal to 0. So linear momentum is equal to constant. Linear momentum is equal to constant. But the kinetic energy is not equal to constant. So this kinetic energy is converted into some other forms of energy, like the sound, heat, light, etc. The loss in kinetic energy appears in some other forms of energy, like heat, sound, light, etc. So the kinetic energy is not conserved here. The linear momentum is conserved, or this remains the constant. So there is always the loss in kinetic energy. So all the collisions in our daily life are the inelastic collisions. Examples: collision between bullets and sack full of this sand, full of sand. Similarly, you can have the collisions on the road. Collisions on the collisions between big bodies on the road, etc. We are having so many other are there, and in all this there is always the loss of the kinetic energy. So this is what the elastic and inelastic collision. They are further divided into the two kinds of collisions, that is the head-on collision and the oblique collision. The one-dimensional collision and two-dimensional collision. The head-on collision is called the one-dimensional collision because the body are moving in a straight line, and the oblique collision because the body collide in a plane and then they move. So this is the two-dimensional collision. So that I will tell you in the next lecture. That is the head-on collision and the oblique collision. So thank you very much.